I think it's time. So welcome everybody to this Mako webinar. I should start by explaining a little bit about who we are. Global Graphics Software is headquartered here in Cambridge. And here's a lovely picture of our office on a sunny day like this one. And we are part of a larger group of companies who develop integrated software and hardware solutions for graphics and industrial inkjet printing. And you can see we've got quite a geographic spread. Now for Global Graphics itself, we have three main product lines. So we have the Harlequin RIP, which is a high-speed, high-performance RIP, or raster image processor for those who are uninitiated. We have Screen Pro, which is a high-performance screening engine. And the subject of today's webinar is Mako, which is a powerful and versatile digital document SDK. And I hope you will agree with that statement by the end of this webinar. So today we are going to show you how you can render a PDF to an image in a couple of different ways. Handling PDF in a web environment, how you can analyze a PDF and find out information about it and get that detail. And we're also going to show you how you can change and edit a PDF with a particular use case in mind, which is variable data. So I'm going to stop sharing at this point so that my colleague can get ready. So my name is David Stevenson. I'm the product manager for Mako, and I'm joined by my colleague Andy Cardy, who is going to show you. Hi, hello Andy. Who is going to show you how easy it is to do some very tricky operations on PDFs using Mako, and he has agreed to the tricky task of writing code live in front of your very eyes. Mm-hmm. So Andy, would you like to just introduce yourself and then we'll get started?
Yeah, so I'm Andy. I'm a principal engineer with Global Graphics, and I also work as a developer advocate for the Mako SDK. So a lot of the times I'm working with customers to understand their problems and help try and solve them using the Mako SDK. That's me.
Cool. Okay, so now we're going to get into to the first of the examples we want to show you. So the first is about rendering. It's a very popular use for Mako, which is to render images from a PDF. These might be something as simple as an RGB thumbnail, or it could be high resolution images. And in fact, you can use Mako to create everything all the way up to fully color managed CMYK separations for printing on a press. A common requirement is a more sophisticated on-screen rendering to correctly visualize what would be reproduced by a printing press or high-speed digital device. So a little more on that later. So Andy, shall we start with a simple case? How do we handle that?
Yeah, so let's start with that. I just had one question and say make it a little bit bigger. So I will try doing that. Excellent. Cool. So basically, rendering is really simple, and I'm going to code this from scratch so we can see how little a code it takes. So the first thing that we need is an input file. So we'll choose to use a PDF. That PDF looks a little bit like this. Let's have a quick look. So this is opening in Mako PDF editor. So under the hood, this actually uses Mako as well, which is quite cool. So this is what we're going to be rendering. A couple of pages, not much to it. So what do we need to start off with? Well, firstly, you need to create a iJaws Mako instance. And what this is it's a singleton instance for the SDK. So const auto jaws Mako. And what you need is to use this in all other subsequent calls when you're creating resources and stuff. It's basically a reference back to the SDK, so you can create your objects. So the next thing you need to create is an IPDF input. And there's lots of other different types of input. So there's one input class per PDL that we support. So there's an IXPS input, an IPCL input, etc., etc. So we pass in the singleton instance of the Mako SDK, and then optionally you can also get progress as well. But we don't need it here because it's going to be so quick anyway. Input. And now once we've got our input, what we can do is we can open up our test file. All nice and simple, hopefully, and straightforward. And then what we get back is a document assembly. Now, what this document assembly is it's a container for multiple documents. So some PDLs that we support multiple documents in one file. So for example, XPS would support this use case because XPS features a fixed document sequence at the root, which contains multiple documents. In this PDF, we only have the one document, so we'll get the first 0 index document. Or as a shortcut, you don't actually have to specify it. It just says get the document, so it gets the first one. So there's our document. And then, so naturally, the document allows you to get the page, and we'll just get the first page. And there's our first page. Now we've got our page, we want to render the whole thing. So what we need for this is a iJAWS renderer. And this is the object that you use to render stuff using JAWS Mako, using the Mako SDK. So there we go, there's our instance. And then to render it, it's as simple as calling one of these APIs here. Sorry, it's probably a bit too small to see, but there's a whole list of different methods that you can call. There's bog standard render, which will just render it using your DPI. We can render anti-alias. We can render in monochrome, or we can screen as well as render if you want to go out to your device. And you can also render to separation. So if you want CMYK output from your PDF, you can render separations. And then finally, you can also render to a frame buffer. So if you want to keep your raster in memory, you can use that method. But we'll just render anti-alias, nice and simple for now. What this call takes is a node. So basically, when you use the Mako SDK and you open up a page, the content of the page is essentially a tree node. So you can take a subsection of that tree and you can render just that subsection, or you can render the whole thing. In this case, what we'll do is we'll say page.getContent, spelled correctly. And we'll render it at 150 DPI. And that's going to render our whole page. Nice. And what we get back is an image. So that will render just the one page, but actually what will be nice, we might as well just render all the pages. So what we can do is just surround this quickly with a for loop. And we'll call this page index, and we just need to know how many pages there are. And there we go. So now we're going through all the pages and rendering them. We just need to put page index there. Okay, so now we've rendered it. We've got the image, which represents a raster. The next thing that we need to do is encode that raster into an output format, and then get it into a file. So we can use IDOM PNG image. There's also other formats that we support. But we'll just do PNGs to start off with. Put in the JAWS Mako there. Oh, no, I'm going wrong. Encode. So we want to encode the raster into a PNG image. And we still supply the JAWS Mako. We supply the image that we want to encode. And then we have an output stream. So this will encode it and send it to the output stream. Again, we have lots of convenience methods to say, well, I just want to output this directly to file. So we can do that very quickly and easily. And then all we need to do is have a file path that we want to output it to. Ooh, wrong place. So this will be our output path. And that is pretty much all we need. Oh yeah, Visual Studio is a bit, I think it's with Sharper actually, is a bit strict on this. It should be able to implicitly convert that string stream, but we just need to cast it down to a const string. So that should output our PNG image for all of the pages. So let me just check that this project is the one that's running. So rendering is selected. Let's give this a go and see what we get. So we have our output here. Start this off. Yeah, there we go. No, because I think I know what I've done. I've put the page on here instead of JAWS Mako. There we go. Isn't that great? And then we run this and we have our output. There we go. And these are PDF pages rendered at 150 dpi, first page, second page. How's that, David? Is that kind of what you're expecting?
Yeah, and your deliberate mistake there proved that we're doing this live.
Deliberate, of course, yeah.
That's very good. That looked pretty straightforward to me. I noticed along the way you introduced us to the Mako Document Object Model, or DOM, by showing us a hierarchy of the JAWS Mako class, a document assembly, a document, and a page. So that's nicely done, and we'll see more of that as we go through this. Now, a common requirement, certainly in the with print, is a more sophisticated rendering to correctly visualize what would be reproduced by a printing press or high-speed digital device. I've sent you an example file, magazine.pdf. Andy, can you have a go with that?
Yeah, let's give that a go. Is my screen okay to see now, by the way? Is it?
Yeah, it looks pretty good to me. You got nice and big.
Cool. Well, I've got this file in my test files directory, so let's render that and see what we get. So we've got our output here. This doesn't look quite right.
No, clearly there's something not quite right there.
Yeah, that's a bit there.
But I know that this is because the designer is using an overprint setting in order to get the effect he needs. I think it's something to do with the ink the word magazine is going to be printed in. So how do we render that correctly?
Yeah, well, actually, that's pretty straightforward, and it takes just 3 lines. So what we can do is once we've got the page, we can just use a overprint simulation transform. So if we create one of these using our Mako instance, just like that. And then what this transform does is it will iterate over all the content in our page or the node tree. You can use a transform on a subsection of a page, but we'll use it over the whole of the page. And this particular transform, what it will do is it will render the objects which have overprint tagged on them. So that means that we'll get overprint simulation using this transform. This transform is really useful where you're going out into an intermediate format. So for example, if you are going out to SVG, you might want to simulate overprint simulation, but you want to retain as much vector content as possible. In this case, running the transform will render just what needs to be rendered, and the rest will remain as vector content, which is quite nice. And there's other options you can use here. You can set the resolution that renders, and you can set other options too. And then we'll just go to transform, and we won't transform a subsection. What we'll do is we'll transform the whole page, and we'll pass it in the page. So now after this call, it should have overprint simulation applied, and then we'll render, and we'll see what we get as an output. And lo and behold, hey, look at that.
Yay.
I think that looks good.
Very, very good indeed. So as you saw, Andy used an overprint transform to make the changes that were needed. Transforms are a key architectural feature of Mako. They make it easy to affect big changes to a page or an entire document with just a few lines of code. Transforms will crop up again before we are through today. And as Andy mentioned, rendering is not confined just to bitmap images. You can also render to XAML for Windows WPF, Quartz on the macOS platform or iOS, or Skia for Android. And as Andy mentioned, there are methods for generating SVG for web browsers. So talking of the web, we're going to move on to our second example. And we're going to build on some of the concepts Andy has already introduced us to for this next example. Another common requirement is to handle PDF in a web environment, enabling a user who is just working with a browser on a laptop or on a tablet or a phone to view pages of the PDF stored remotely. We now switch context to a web app. In fact, Andy's already got it up on screen, written in C# this time. So that Andy can show you how this can be done. So Andy, where do we start? Do we start with the user's request?
Yes, we do. So this is a method that takes the user request. So what we're developing here basically is a REST API. So it's a single REST API that has a URL. And when we access that URL, we're going to use Mako to load up a remote PDF, and we're going to render that and send it back. So the REST API will return the image. And this can be useful for a whole host of different reasons. And we've used it with success in the past. So let's see how we do that. So the thing to notice about using Mako using C# is that it should be fairly intuitive because it's very much the same APIs, just wrapped up using C# instead, which can be quite convenient, really. So what we'll do here is we'll start off with this code, and we have a URL. This is a localhost URL, but it could be anywhere on any domain. And what we'll do is we'll have an iPDF input, much the same as our rendering example had. So we have our iPDF input here, but in C# it looks slightly different. What we do is, instead of using a stream to a local file, what we'll do is we'll use a stream to this file here. And what this means is we give Mako this stream, and whenever we access content in the PDF or the document, Mako will request through that stream just the bytes that we need. So that means that we don't have to load the whole document in one go, which is very convenient, especially with larger documents. It will just request the bytes that it needs. So that's what we've got here. We're getting the length of it so it knows how far to go. We're creating the input stream using our convenience HTTP reader, and then we're opening it using that stream. And then the usual kind of code exists to say, get me the first document and the first page and get me the content of that. So what's next? We'll just go ahead and render it. We've got our content to render. So we can, the same as the last example, create an iJAWS renderer. And then we can render anti-alias to the same DPI as we used last time. And then we have our rendered image. For convenience, let's just write this out to a temporary location. So we're encoding this to the PNG and just writing it to disk. Obviously, in a full implementation, you'll want to keep this in memory, which is fine and achievable, but just to reduce the amount of code that we have, because you don't want to see me writing or copying too much code, we will just write it to disk. And then we open the stream to that file on disk, and we stream it as a response. So that's all of our code, and it's not too much. Let me set that as a startup project. So I can run this up now. It will go to the root, and then I'll open up the REST API URL, and then hopefully we should see. So if we go to render, which is my API, we should see, there we go. That's the first page of the document rendered. And if we have a look at the test files, it's quite a, it doesn't look big, but it's got like a couple of hundred pages, 226. So it is just requesting what it needs. How's that?
That's really good. But you're just showing us pages at the start of the document. What happens if I want to go straight to page 144?
Ye of little faith. It is working, but I can show you that as well. Let's have a go. So what we can do to show that off is we can put the URL in as a parameter to the API, and then we can put the page index in as well, which is what you're probably really looking at. So instead of having this hard-coded URL, we have that in there. And then with the page index, where we get the first page, we're now getting the page index. So let's have a go at this. So same render, but this time we're using URL. So we can see here we've got the URL that we want to render. So this is URL to PDF, and then the page index, 0. Oh, haha. Got a page you want to go to?
144. I don't know why, but seems like a good page. There you go.
There you go. That's pretty quick.
Okay.
I'm happy with it.
I'll believe you. Very good.
There we go.
Yeah, that's cool. I know, of course, that to make this work well, you need to publish linearized PDFs, aka web-ready PDFs. And of course, Mako can let you do that. There's a setting on the PDF output class that allows you to specify that for PDF output. Excellent. Okay. Right. So we're going to move on now to our third example. We're back with C++. Am I right? Yes.
You are. Good. Right. Yeah.
So the thing about the PDFs is that before you go about making changes to them, you need to know what's inside them. And in fact, knowing details about the content of what you're dealing with is vital. A lot of times, well, pre-flighting for print is a sort of well understood concept because you need to be sure that you're going to get the correct result when you start printing, thousands of a particular item. But that's just one aspect of document analysis. What Mako offers is the ability to create custom analysis tools that then can mean that you can accept, reject, or determine a document's route through a particular workflow, or just simply account for paper or ink usage, something like that. So Andy, are we going to be delving deeper into the Mako DOM for this example?
Yeah, let's go a little bit deeper. So let's start off with some simple code as we've seen before now. What we'll do is we'll open up that datasheet PDF. If you remember what that looks like, it is this one here. And what we'll do is we'll add a couple of examples of how you can go through this document and have a look at the text, the images, if they have images on the page, and we'll have a look at that. So what we're doing is much the same. We're opening it, we're creating our singleton instance of the SDK, opening the input, and then getting the document back from the assembly. And then we'll just iterate through the pages so we can analyze each page independently. So the first thing that I want to take a look at is how we go through the DOM and see what images we have. So I've got a very small little method here called report images. And what that takes is page content. So when you call document.getPage and then .getPage content, it will give you back an ifix page. And this is like the root of the node tree. So when you get content from a page, this is the first node that you'll get. And then from here, you can look down the tree and see all of the other nodes. And what we're doing is we're saying, based on this root node, find me all of the children which are a path type. So that might sound a little bit odd because we're reporting images, but images are just essentially a path with an image brush. So what we do is we get all of our path nodes, and then we cast them to a path node, and then we say, does it have a fill? If it has a fill, does it have an image brush? And if it does have an image brush, then we know it's an image. And then you can do all sorts of other stuff with this. You can delve into the path node data. So path node, you can get the, you probably can't see this because it's too small. You can get the path data, which is essentially the geometry that makes up the path. Anything to do with it, you can get the color of the brushes if it's a solid color brush. And then once you have the color, you can get the color space that it uses. But in this case, keep it simple. Let's just report the images. So what we'll do here is we'll say report images. and then we'll say document.get page index, and then we just need to get its content. And let's just make sure that we've got this set so we don't run the previous project. So this should go through this document, each page, and report whether it's got images on that page or not. It's simple stuff, but it's getting used to how the SDK is structured and how you iterate through nodes and stuff. And I would say that's pretty straightforward and spot on. So number of pages in the first page is 1. We had that image in the front, and then there's no images on the other page, which to me makes sense. So the other thing that I'll show today is around glyphs and fonts, so text in PDF. So of course, I mean, the written language is so important, so we've got to be able to access it through the PDF. And how we do that in Mako is that we do the same kind of thing we call find children of type, but this time we're interested in the glyphs nodes. And the glyphs nodes represent a run of text. So what Mako tries to do when it opens up a PDF, for example, is that all of the text that's positioned on the page, it will try and create runs of text out of it, instead of just having small little snippets of text everywhere. So these are runs of text. And then what we can do is we can go through all of those glyph nodes, which represent the text, and we can say, well, what font is that using? And then we can output down here the name of that font that we've got. And we support different types of fonts, true type, open type, type free. You can access all of them. You just got to work out what type it is by either casting or using get font type. So here we're just getting the font. We're also getting the text that's represented by this node, and we're substringing it because sometimes it can be a little bit long to output. And then we're just outputting found the text, blah, with this one. So let's give that a go then. So let's just put that down here. Actually, I'll tell you what, we've run that one actually. Let's call this one on its own, just so we're not confusing things. So draws Mako, and then much the same, we want the page content. Get my selections right. Just make sure that is definitely page content. Good. So let's see what this one does. Cool. Well, that was pretty quick. So it's gone through both of those pages, and you can see that it's found all those glyph nodes. The glyph nodes contain text, and we've had a look at the font, and we can see that it's using particular types of fonts. So that's all pretty cool. And then it goes through the second page as well. Is that the sort of DOM stuff you were expecting, David?
It was, and you've given us a bit of a whirlwind tour there.
It is a very quick tour, yeah.
But it just demonstrates the level of detail that you can get into with the Mako SDK. So I mentioned toner usage before, and we have Mako users who care deeply about the number of color versus monochrome pages in a job, so that they can make cost estimation accurate. Can this be done with Mako? How would you go about doing it?
Yeah, it can actually. So very simply, we can try this out actually. So what we've got here is a little method called report color pages, and it will take a page and it will tell you basically whether the page has color or not. And to do that, what we do is we use this simple color reporter, which I've created. And what this simple color reporter is it's an implementation of a custom transform. So despite the name, custom transforms are obviously used for transforming documents, for transforming pages. It will go through the node tree, and it will give the writer the opportunity to edit nodes as it goes. But as well as editing and transforming, custom transforms can also be used just for analysts and reporting, which is exactly what we're doing here. And the reason why they're so useful for reporting is because instead of going through and finding all of your children and then finding colors and then finding color spaces, what you can do is in your reporter, in your implementation, you can override a method which says, I'm interested, when you go through this page, about all of the colors that are being used on that page. So you don't have to write the code to find all of those colors. It's done for you in this custom transform implementation. So all you have to do is say, I'm interested in colors. And then our implementation is very simple. So it will give us the colors that were on the page. And for each color, we say, is the color space of that color device gray or S gray? If it is, then it's definitely grayscale. Easiest one. Let's just return. Otherwise, you can delve into stuff. And now this is a very simplified version. So you'll probably want a full implementation to be a little bit more, check a little bit more things, basically. But for now, we're just going to say, well, if it's not device gray, let's just double check if it's CMYK and if that CMYK represents gray as well, because that's a very common thing to use CMYK, but just use the K channel. So that's what we do here. So if the color that we've been given has a color space and that color space represents gray, then return. Otherwise, it's got color. And then if it's any other type of color space, then we're assuming that it is color. But like I say, in a full implementation, you'll want to fill this in a little bit more and check more color space magic that you can get from Mako. So that's our implementation. And then to use it is really simple. And I love this. So you just create a custom transform using our color page reporter. And then we just call transform page. So this call internally will cause Mako to go through the node tree, and it will call our method as we saw. And then after it's gone through the whole page, we can call this method, get content has color, and this will return true if the page had color. So let's run this with a slightly different one. So we have a document in here, which is datasheet Mako color gray. And all this is, it's a datasheet. But I've concatenated 2 more pages to the end, and these pages are just black and white. All right. So I'm expecting first 2 pages to have color, second 2 not to have color. Are we calling this? We are not calling this. That would have been an excellent thing to show. And I hate that very much. Right, there we go. JAWS Mako, and the page that we're interested in. So get page. And then the index of the page. So let's give that a go. I did not change the PDF that I'm using. Color gray. That is definitely the right one. Color gray. Yeah. Got it right though. There we go. So first 2 pages, as you remember, had color. Second 2 pages were grayscale, and it's identified correctly that it doesn't have color. Is that good?
Very good. I too love custom transforms. I used one just this morning to fix a customer issue to do with PostScript generation, interestingly enough. Anyway, that's another story. You touched on the color capabilities of Mako there. With its built-in color management module, Mako, we should let the audience know that sophisticated color transformations are possible using industry standard ICC profiles. So you saw Andy using the color management module to identify color spaces, but you can also use those to make transforms, change the output intent of a PDF. Some very sophisticated color operations possible with Mako, and you can build those into preprocessors for your particular workflow. So I can't believe this, but we are actually on our final example. Time really has flown by. I can't believe it. So far we've seen Mako working with existing content, but what if you need to generate new content, perhaps derived from a database? One of the opportunities presented by high-speed digital printing devices is personalization, and it's certainly something that we're seeing our customers do more and more. In the past, of course, the high setup costs for professional printing meant the higher the volume of the exact same printed piece, the lower the unit cost, but a digital device can in principle, produce different content with every impression. So you saw with the web demo that we can use a raster image processor or RIP to digest new content. And we do obviously exactly the same with printing. But if the page raster is not ready on time, that may mean that the press cannot be run at full speed. And obviously that is something a printer wouldn't be very happy about. So what we're going to do now is we're going to take a look at some techniques for adding variable content to a PDF. So Andy, where do we start?
Okay, so what we'll try and do with this code is we'll start off with a template PDF. So a PDF, single page, and what we'll do is we'll duplicate that page, say 100 times, and over the top of that duplicated page, we'll put some variable content. We see a lot of people adding barcodes and such, so we'll add a QR code on top of this repeated data. So we'll use this template PDF, which is essentially just the Mako data sheet. And we'll add a little barcode on each one of these pages, which is different. And we'll make sure the QR code text is different, so the barcode is different as well. Does that sound all right?
Sounds like a plan.
All right.
Certainly the kind of thing our customers want to do, that's for sure.
So let's give this a go then. So I'll add in some simple code again. You've seen this before. We open up the template file and we get the page back and we can start using the page. So one of the things that you can do with Mako is you can stream output. So if you have a large amount of pages that you're generating from scratch, you can stream that out rather than accumulate all the pages and then write them out at the end. And this really helps with memory overhead, because if you're doing, say, 10,000, 100,000, a million pages of this variable content, you really don't want to be keeping all a million pages in memory. You wouldn't be able to. It doesn't scale. So instead, what we're going to do here is we're going to introduce the document writer. So what we do is we create a PDF output and we call open writer. And what this does is it allows us to stream the pages one by one, just writing each page as and when we're ready. So what we do is we call begin document, we write our pages, we clone the page contents. This is the template page, we clone that content, we add the variable data over the top to that new page, and then we write that page out. And then at the end, you just say, well, I'm done, end the document and finish. And then the rest gets flushed. So this should take that first page from the template and copy it 100 times with variable data over the top. Let's see if it works. And let's see if I've set the, yes, I have. So let's wait on the output folder as well. There we go. So we can see it's creating those pages fairly quickly. And we're doing just 100 this time. And there we go, we have our output. A couple of megs in size. Let's have a look. And there we go. So there's our little QR code that's there. And that changes for every single page, whereas the content at the back remains exactly the same. How's that?
Very good. It took a little while to process. I mean, you've got a fast laptop, so it didn't take that long. But I do notice that the output has grown somewhat. You're only doing 100 pages. If we were doing 10,000, we would be into much bigger files.
Yeah.
Is there a better way that we can do that with Mako?
Yeah, so we're thinking about the memory footprint, and that probably didn't rise too much. But you're right. The other thing is, are we creating a efficient PDF? Because actually, we probably aren't here. And you're right to point that out. If we have a look at the page structure, we can see that all of this text, all of these vector content bits and stuff, they're repeated for every single page that we've got. So actually, you're right. I mean, it's very memory efficient, but in terms of an efficient PDF, it's maybe not so. So let's see what we can do, and we can do something. And what we can do is we can use a concept called forms. and this is a PDF concept. And what this means is a form is basically a container of content. So if you think about that template page, we could take all of that content and put it into a form. And then what we can do is, instead of adding the content to each page, we can add a reference to that form on each page. So each page now only contains a reference to that content. It doesn't contain the content itself. So that's going to be much more efficient because we're declaring the content once in the form and then referencing it. And actually, it's not too hard to change this to get it into that form. So what we need to do is, just before we start writing stuff out, let's move this page content into a form. So that's taking all of the stuff on that template page, moving it into the form. And then what we can do is down here, instead of cloning the page, what we can do is we can create a new page, which will be completely empty. So there's nothing in it. And then what we can do is we can say, get the content back. So new page content equals the new page, and then get content. So this is empty at the moment. This is just a fixed page without any content in it. And then what we'll want to do is we'll say, create a form instance. So we have our form instance here, created our form instance, and then we're saying this instance should reference the form which has all the content. Okay. And then all we have to do is say new page content, pen child, and then the form instance. So you'll see that there's only two things being added to that page, the form instance, which is a reference, and the QR code. So this should be pretty slim. It was 2 megabytes before. Let's see how much it's slimmed down to. See if it's any quicker as well at outputting. Ooh, that is quicker. That is good. Ah, there we go, 300K now. So that has gone down significantly. So let's have a look at the page structure then. So now we've gone from having all of that content on the page just to being referenced. So none of these pages contain that content. It's all a reference to this form. So we just have the reference and the QR code. How's that for efficient?
That is really good. Yeah, I'm suitably impressed by that. The other thing I know is that using forms or X objects, as they're also known, RIPs such as the Harlequin RIP will recognize a form and will render it once. If it's used repeatedly, we'll render it once and then use that same cached bitmap again and again. And that really makes a huge difference to the speed of ripping. So so with Mako, we can target efficiency right into the PDF when it's being created. So that's really good. I'm going to switch back now.
Oh,
so Andy,
yeah, do you want me to
stop,
I'll stop sharing. Yeah.
Yeah, that'd be good.
If I can find out how. Oh my goodness. Oh, it's up here, isn't it?
Yeah.
So stop share. There we go.
Okay, and I'll share a screen. I think it's that one. Oh. We've got some questions here. That's good. All right, you can start looking at those, Andy.
All right.
While I just talk to this. So today we showed you how to render a PDF to an image using Mako's built-in RIP. So you saw a lot of references to JAWS. Now, those who know global graphics of old will know that we have another RIP technology called JAWS, and now that's fully built into Mako. Has become part of the Mako product. So the high speed and high precision RIP capabilities that JAWS offers are now built into Mako. We also saw how you can handle PDF in a web environment using a C# app. The technology actually was Windows technology, ASP.NET Core. And we also saw how to, we saw a glimpse into document analysis. I mean, Andy went through a couple of things there to do with images and fonts, but there's a lot more when you get into the Mako DOM. And the last example that you've just seen, we were editing a PDF, taking an existing one and adding variable data, which is a popular application these days. So there are our contact details if you'd like to get in touch with either of us directly.
Oh, are you sharing that, David?
I am.
Okay, probably just me then.
I'm definitely sharing. I think I'm sharing. Yeah.
God,
Oh, maybe I'm not sharing. I was talking.
There we go.
Yeah,
now
there
we
you
can
go.
see it.
Okay,
Sorry.
so there you go. That was my bad, as they say. All right, let's go back. Yeah, so that was my nice little summary there that I had up on screen, but unfortunately I wasn't sharing at the time, so apologies for that. Anyway, those are our contact details. And if you have any questions now, then you're very welcome to pose them through the Q&A panel. We'll try and answer them here. Alternatively, if you'd like to contact either of us and learn more or have more questions about Mako, what it can do or what it could do for your company or your application, then please talk to us.
Cool. So we do have a question. So Stefan is talking about using the Knuth class algorithm, which is to do with layout analysis in certain ways, if I understand it correctly. So we have layout analysis already kind of baked into Mako. It doesn't run by default. I mean, we do a little bit of analysis at startup when we're opening PDFs and stuff, but not too much. We just take individual characters and stitch them together if we need to. But we also optionally have the ability to analyze the layout of text on the PDF. So what this does is it will use heuristics and intelligence to work out basically what your columns are, what your paragraphs are, what your lines are. And then that can help you with stuff such as searching or text selection. So out of the box, we already have that. I mean, you can access as much as you like of the glyphs and fonts and bits and pieces. Yeah, so it's a paragraph breaking hyphenation algorithm. So you can access as much as you like out of the glyphs and the fonts and stuff. You can get to some really low levels of them. So I'm sure what you're thinking about is possible, but I'm not sure I entirely understand at the moment your area that you're talking about. So maybe this will be a good one to maybe spin an email to us over, and we can discuss it. David, do you have any more insight into this one?
Not really, but I'm very confident that the level of detail you can get to with the glyph objects in Mako.
It always surprises me, actually, because I was working with a customer just today, actually, and we're trying to get the metrics of the fonts, so like how much the descent is from the baseline, that kind of thing. And I know we can do it internally because we use it all over the place, but I didn't know if there was an external API. And it turns out you can get it. And you can also get access to all of the font tables and bits and pieces. So if there's anything you need to know about the font in terms of metrics, that's all accessible as well. So it is surprising even to me how much you can get to.
Well, that's good. That's yeah, that confirms what I thought. But good to actually hear that there's a practical example of that. Very good. Okay, well, I think we are. We got another
a little bit more time.
Few more minutes to go. So, if there
is
any other
Q&A
questions?
panel if you want to add questions in, if you can see that. But if not, we can hang around for a little bit just in case.
Yep.
But yeah, other than that, thank you very much for attending, and I hope it was useful. I hope you learned a little bit from the code. Yeah.
Yeah, I also would add my thanks to the audience for attending and sticking with us. So I guess another as a thanks on the Q&A. So if there are no other questions, then I guess we can bring this webinar to an end. So I'm talking now to our producer, Paula, who will end the
I'll
broadcast.
press the end button. Yeah. Okay. Thank you.
Thanks.
Thanks, Paula. Bye.